Okay.
So thank you for the introduction, Alper. So my name is Christophe Weisse. My new job title is Senior Application Engineer.
Yeah,
It is
I am
just
sorry about the title. So
no, no,
yeah.
that's fine. You can see as well that we are now part of ANSYS, so we are still part of the Zemax team, but we have been acquired by ANSYS end of last year. So it came up with some updates, including the job title. So it's perfectly fine, but it's still me. So no changes from that point of view. So in this presentation today, I will focus on the latest updates. So the updates included in the 22.1 release of all our products. So as introduced before, so Optic Studio is of course our main tool to design optical systems. We have Optics Builder to streamline the workflow between Optic Studio and CAD programs. And new from last year, we have the STAR module that also bridges the gap between FEA analysis tools and Optic Studio. By the way, the STAR module received the Prism Awards winner. So it kind of shows that it is quite well. It is raising quite a lot of interest on our users' site. And really, our goal is to support not only optical design using traditional, let's say, Optic Studio sequential mode, but also, well, non-sequential mode as well. Optics Builder, so to also ease the communication with the mechanical engineers, but then also with the STAR module, we now have a nice tool to very easily use the results from FEA analysis tools and update the initial Optic Studio sequential design. And this is just an example that shows how our let's say, historical Zemax tool can communicate together and help you improve the workflow. But now that we are part of ANSYS, there are other tools that can also very easily be brought into that loop. So this is an example using, sorry, ANSYS Mechanical, but you can think of virtually any other ANSYS products as well. That being said, so let's focus first on Optic Studio updates. So what was new beginning of this year? So in the January release, 22.1, the next release being the 22.2 end of May, so in a couple of months from now. So the first update is enhanced ray aiming tool and a new algorithm. So we have put really a lot of efforts in this one to improve speed and stability when you need to use that option. And when would you need that? Well, for any wide angle system, right? When you have a really wide angle system, then let's say the default mode kind of sometimes struggle to fill the aperture properly. So you need to use an alternative method here. And this is called ray aiming. And it applies to a lot of different applications like machine vision, surveillance cameras, drones, autonomous vehicles, cell phone lenses, you name it. And as you can see, so you have like an additional option here, and so it's working quite well, but it adds another option to a list of already available other options, and sometimes it might be tricky to figure out what is the best combination of settings for your particular system. So this is why, besides the new algorithm itself, we also came up with a wizard. So for now, it's in the feature experiments. which means it is still in a beta version, but will soon be available as a regular feature that will help you basically based on well how your system is defined, that will recommend you what are the best settings for the optimum ray tracing into your system. By the way, you can see from the future experiments list that we are also working on new optimization methods to provide you with alternatives for possibly converging quicker and better to the optimum solution as well. And by the way, feel free to ask your questions as soon as you have any. I'm happy to pose and answer your questions on the go. Right. So next topic would be new native volume holograms options for non-sequential objects. So this is actually part of a topic we have been working on for some time now, because it all started in 2020, if I'm correct. We basically added new algorithms to compute diffraction efficiency for volume holograms using the Kogelnik method, or for gratings using the rigorous couple weight analysis method, or RCWA. And this is really a change because you are now able to, compute the diffraction efficiency of those diffractive optical elements versus wavelengths versus angle, or both at the same time. And so it was first available through DLLs, but then the volume hologram solver was added to the existing sequential surfaces, and at beginning of this year to the non-sequential objects as well. So it kind of spread along the existing native OpticStudio objects to enable you to use those kind of advanced solvers even more efficiently, and also have some additional insights about how the diffraction efficiency changes over a number of parameters. The nice thing as well is that you can use those parameters to optimize the performances not only of the diffractive optical element itself, but of the whole system. So you can use only OpticStudio to do all the needed computations. Right. Next topic. Oops. What am I doing? My mouse seems to go crazy. Okay, I will stop here. So project directories. We had number of remarks about the folders you needed to use to place different kind of files. All the accessory files, but that are important to completely define your optical design. So it can be a glass catalog, a coating, a scattering profile, a spectrum, a CAT file if you are using a non-sequential mode, and you would have to use specific folders to store that data. And now you can use a project directory. So basically you would be using a different folder to store all those accessory files, and this allows a project by project approach. It's easier to share sometimes, and it's also working together with the archive file, so the ZAR files basically. And so you can also choose to extract all the files from an archive file into a specific folder and not into the default, Zemax folder. So it really adds a lot of flexibility regarding the workflow. Next topic. So it's a new non-sequential object called the off-axis mirror. and it's part of also potentially have a better definition of non-sequential systems and a better exchange between Optics Studio and Optics Builder. So any surface, right? Any mirror surface from the sequential mode that has either also an offset, a conic, polynomial terms, even user-defined apertures can be converted now into a single, a native non-sequential objects, and yeah, that's really just making your life easier when working with any kind of those mirrors. It can be also quite useful when you are trying, to fit an existing design into a smaller space. Then you would need to add a folding mirror, and that also adds to the ease of conversion. Other updates, so we also regarding the workflow, so there has been an update in the Prepare for Optics Builder tool to enable a chief ray trace directly in CAD environment. So I will explain later the benefit for that. We have also added, speaking of communication, we have added a new templates and examples to create those API applications using Mathematica on top of all the other existing languages, C#, C++, MATLAB, and Python, just to provide you with additional options here. Any questions so far? I'll take that as a no. You will have time at the end of the presentation if you think of additional questions to ask those as well. All right.
The project folder approach.
Yes.
Sounds quite nice. Apart from all the technical improvements, this will make the organization, file organization, I guess, better. Right?
Yeah, definitely. And so for now, you have simple options to convert an existing, file into a project directory one. But we will add other options to allow for additional control over different parameters here. So this is really I think, yeah, a nice a nice update in terms of usability.
Let me also make a Turkish announcement about questions. If anyone wants to ask a question in Turkish, it's totally okay. Türkçe soru sormak isteyen olursa her zaman soru sorabilir. Kendini unmute edip sesli hale getirerek veya chatten yazarak sorabilir. Okay.
Hello, I have a question.
Mm-hmm.
This is Mutlu from Ankara company Optomek.
Merhaba Mutlu Bey.
Merhaba hocam, nasılsınız?
İyidir, siz nasılsınız?
Ben de iyiyim, sağ olun. My question is about this diffraction efficiency.
Yes.
With that one, we will see the diffraction order efficiency for example, if you make a diffractive lens.
Mm-hmm. Yes, exactly. So you have actually several options here. So we have added those features a long time. So it started actually in 2020, and we have added 2 new algorithms to Optic Studio. So the cogonic method for volume holograms and the rigorous coupled wave analysis for gratings. The goal of those is to really define the exact structure of those diffractive optical elements, so that we can use, well, those specific solvers on the component level to kind of compute, well, the exact diffraction efficiency based on the exact geometry of those elements. So we have, if you are interested in that topic, oh God, I have too many windows opened, but if you go on our website, you know, we have a quite nice knowledge base. You can find additional information here. You just need to type Kogelnik here for the volume holograms, you know, knowledge base article, and then you have all the explanations here. And we have a similar, very nice knowledge base article for the RCWA method. And so, yeah, you have all the explanations on how those algorithms work. And then you also have example files also towards the end of the article. So you have really a lot of very useful information in there.
Okay, thanks.
Yeah, quick note also about that. So we are also working on a project to have a better, you know, interoperability between Zemax tools and Lumerical. So in, well, midterm, you will have also additional, well, options to even better define and optimize and you know, those kind of elements. While I'm sharing my screen here on the on my browser, I would like to take this opportunity to introduce you to the user groups. So this is a new part of our community part. So for our supported users, so we have a forum here with general question, code exchange, but we have recently added user groups. So this allows you to retrieve all the questions that are related to a specific tool or module. So for, oops, I'm not, yeah, I need to log in, but you would find a lot of useful articles that focus on specific aspects of the workflow, and you can see it is quite quite a good place to find a lot of very useful information. All right, so actually good transition to the next topic, which is the star module update, unless there are other questions.
About user groups, Christophe, do we have to have a active Zemax account to join?
Yes, it is for supported users. So all the content that is on the community part of our website is really, well, for our supported users. The knowledge base articles are freely accessible, so you don't need to log in or register. Whatever, it is really ungated, so you can access them really freely, and it can also provide you with well, very good feedback and additional information about how to use our tools.
Thank you.
Sure. So star module, so but just to remind everyone of what it is. So it is a new module. You can see here it is integrated in OpticStudio's interface. It allows you to well, load, fit, and use FEA data, sorry, from any FEA package. So you basically you just need to load FEA datasets into OpticStudio, and then your whole model is updated, and you can use any OpticStudio analysis tool, optimization, tolerancing tools to, well, gain additional insights about how your full system behaves. So you have new tools that are available through the UI, but you also have the exact same options that are available into our programming interface to allow you for full automation of your process. So it is a new module. I think we can start to use new wish because it was introduced mid last year in May, I think, so almost a year. So way younger than OpticStudio, that is more than 30 years of age, of experience, let's say, and the star module is still new. So similarly to OpticStudio and its regular updates, we are also updating the star module on a regular basis. So the biggest improvement feature-wise in the 22.1 version was to add different numeric fits for all the wavelengths that are defined for the system. So previously you had, only one wavelength at a time that was available, and now you have the option to use, well, different wavelengths. This is particularly useful because, well, not only can you import structural data, so the surface deformations, but you can also import thermal data. So we are using the temperature map, so the repartition of the temperature inside an optical element to compute the change of the refractive index. So using a gradient index material with a non-uniform grid. So it of course varies over temperature, but it can also vary across wavelengths. So now you have both parameters that can, be taken into account at the same time, and you have additional controls here into the star analysis to focus on a specific wavelength. Based on the remarks from our early adopters, we have also added an FEA data viewer, so you can actually look at the FEA data you want to import. So you can show the dimensions, so you can realize maybe beforehand that maybe the units are different. I'm mentioning that one because I was tricked myself trying to use an FEA dataset that was using meters as a unit and not millimeters. So of course it wasn't matching very well. You can also review the number of points that has been defined by the FEA meshing tool, and any kind of preliminary insights you would like to have regarding the FEA dataset you want to use into the star module, and then you can of course load the FEA data, apply it to your system, and just look at the performance impact. We have also added additional insights regarding the thermal part of the process, because the structural change is quite easy to see in OpticStudio. You can always open a sag map and see, well, the sag difference, so you can quite easily see what is the impact also visually on the structural changes. But the the index variation due to the non-uniform temperature inside a particular element is quite tricky, and also how important it is regarding the impact on the optical performances. So we have this new thermal index plot that kind of indicates what is the actual change of refraction index along the temperature range, and also a reminder of what is the variation of the index over the temperature for a specific material, and you can see the actual index change as well. And yeah, and also we have additional options to really focus on the actual index change on a specific element. So you can really see either the index change or the actual index that is defined for a particular element. So you can really ensure and be confident that the values that you are using are realistic and in line with your expectations, and also get additional insights about what's happening in your system. Do you have any questions here about those star module updates, or the star module itself, maybe?
Star API is working with, again, MATLAB, Python,
yes,
C++,
yes.
all of them? Or?
Yes, indeed. You can use, well, so you can use any of the, let's say, the options we are referring to, so C#, C++, Mathematica, MATLAB, and Python, yes. The programming interface actually can be used with any program that has a .NET interface. So this is really a standard communication channel that is defined on on Windows. So it is shared by really a lot of applications. So I know I had the question once, but in principle, you could also use like Excel as well to kind of program the API. So it is really quite flexible. All right, let me go to the Optics Builder update. So yeah, just as a reminder, so Optics Builder is a CAD add-in that allows you to automatically convert and build systems from Optics Studio into Optics Builder, and also assess the impact on the optical performances when you add mechanical parts. So you can ray trace directly in Creo and check, let's say, the quality of the packaging, and so it saves you quite some back and forth loops. And when the system is, let's say, ready, you can also export it back to Optics Studio so that you can ask the optical engineer to make a final check or in-depth analysis, just to validate your optomechanical design just by a single button click. So it is really easing the workflow, saving quite some back and forth loops, and also saving a lot of manual steps that would that are likely to cause some errors in the process. I told you about the prepare for Optics Builder update tool in Optics Studio, basically to properly define a pupil that allows us to trace the chief ray directly in Optics Builder. so that you can have a reference, especially for systems that are using mirrors or any kind of off-axis or non-symmetrical system. It is very useful because the chief ray is really well, can be used as a reference to position the other elements. And so this chief ray can not only be displayed in Optics Builder, but it's actually an object that the CAD user can click on any of its segments actually, and use any CAD tool to position, mate other elements, or simply measure the actual distance between, I don't know, the ray and the housing, just to be sure you have some margins, and so on. And the best part of that is that it is dynamic, so it's updated with every ray trace. So it means that even if you move an element inside Optics Builder, just because you need to I don't know, save some space into the system, and you want to see what would be the effect of moving one of the elements, then you can update the ray trace inside Optics Builder and continue using this GIF ray to mate the other objects, for instance. We have also put quite some efforts into sample files. We were using some sample files already. So with optical designs, so starting designs and final designs with all the mechanical parts, we have added a lot of new examples, new sample files, just to provide users or any of you who would be interested in Optics Builder with starting points that are closer to the particular use case. So some of them are like really nice. The cell phone camera lens, the ultra short through projectors. We have also a cube satellite example, laser, a high power laser system, so that also shows that works in combination with ANSYS mechanical to show the thermal lensing effect, and so on. So those are really, sample files we are using in all our tools now as more or less standard, to also show the benefit of a complete workflow in terms of time saved and potential errors being avoided, and accuracy, and ultimately to get the product right the first time. Right, so a lot of efforts that are being saved. That being said, so yeah, some usability updates. So of course, we have updated Optics Builder to support OpticStudio's new off-axis mirror. We plan also to continue that effort. We have also a new Optics Builder for Creo 7 version. So Optics Builder now works on Creo 4, 5, 6, and 7. Quick note here. So we are also updating the OpticStudio dynamic link for Creo, because until now it was working only with Creo 4. Coming up soon, OpticStudio's dynamic link will be supporting Creo 4, 5, 6, and 7 as well, just to match Optics Builder, options. All right. And that's all I had in terms of slides. I think we are pretty good on the time, aren't we, Alper? But
yes,
if you have,
yes, yeah.
But if you have any additional questions you would like to ask about this presentation, or any other question about our tools, I can try to answer those as well. So the floor is yours.
Yeah, thank you very much. Soru alabiliriz. Soruları Christophe Bey için varsa chatten veya kendinizi sesli hale geçirerek. Just not about the presentation, but before the meeting, actually, Barış Bey asked me about integration of Zemax with ANSYS. Can you comment on the outlook, like about future plans? Like, will Zemax be like a sub package of ANSYS? Is that the outlook?
So let me use that slide as an example. So a couple of remarks here. Well, first of all, I don't know the exact answer to that question because it's an ongoing process. First of all, so this year it's really an integration year, and we are first of all looking at enhancing the communication between different ANSYS tools as well. This is actually looking pretty good because OpticStudio has always been a package that was quite easy to connect with other tools. So even before the acquisition, and I mean for some features way before the acquisitions, we had options already to exchange files with Lumerical, for instance. Spios already had the Spios lens importer that is actually using Zemax, ZMX, or black box files to use a reduced order model to use in Spios simulations. We had also options to communicate with OptiSlang, which is another ANSYS product to make optimization on system level, so you can connect different simulation tools and optimize on what is the best combination between all the different physics. And so we are working on, you know, enhancing those existing communication channel. We have also added already an ACT extension to ANSYS Mechanical, so that if you are using Mechanical as your FEA tool, you can directly export results with a single button click. You have a dedicated tool to export the structural data and the thermal load into files that match the star file, you know, definition and structure. So it is really an ongoing process, and so it is an integration that is not only focusing on the different tools from the optics ecosystem of ANSYS, so Lumerical, OpticStudio, and Spios. By the way, each of those tools focus on a component, let's say size, because with Lumerical you are really looking at the nanoscale. With OpticStudio you are looking at the micro scale, and Spios the macro scale. So typically Lumerical is for sensors or, you know, diffractive optical elements as well that are more complex, and other very small components. Then you would be able to very easily use OpticStudio and all our tools to design the optical system. And with Spios you can really do a simulation on the system level, including, you know, the for instance the weather